Okay. Let's go through a few of these first. Which graph best represents y equals 3 to the x? Y equals 3 to the x is an exponential function. What did you guys pick? B or D? B? B is a hyperbola. Yeah. D is an exponential. Any reason?
All that
This one? Yep. You're right. All right, D. Let's go. Next one. Number 2. The diagram shows a graph of an equation. Which of the following equation describes or does the graph best represent? Okay. The first one, let's talk about it. What is it? Hyperbola. Hyperbolas look like this. 3 to the x plus 1. What's that one? Exponentials. And then what do those look like? They look like this or like that. And then 3x squared, parabola, looks like this. And cubics, not really part of the course, but they look like this. So the answer is C, parabola. All good? If you want Christian, you can sit next to Christian. It'll be a bit easier to see. All good? All right. Next one, number 3. Which of the following best represents the equation of a to the x, where a is a positive number greater than 1? Okay. Good point, because you can knock off a and b straight away. They're straight lines. You're tossing up between c and d. If a is a number greater than 1, then it's still d. Exponentials start from at the 1 location. Why? If I've got a to the x, any number, so let's say 2 to the 0, 3 to the 0, 4 to the 0, anything to the 0, because x is 0 here, will always equal to 1. Guys at home, any questions? All right, let's do a few more then of these applied style questions. The time for a car to travel a certain distance varies inversely with its speed. All right, inverse variations or indirect variations usually were represented like this. K on x, right? So what kind of function is that? Hyperbola, so varies inversely, is not C, is not D. B looks like a exponential, so also not B, it is A. Which makes sense. Let's have a look at it one more time. As speed increases, time decreases, which makes a lot of sense. Okay, move on. Let me know if I'm going too fast, especially you guys that are at home. The number of hours that it takes for a block of ice to melt varies inversely, there's the word again, with the temperature. At 30 degrees, it takes 8 hours for a block of ice to melt. How long will it take the same size of ice to melt at 12 degrees? The logic is to always find K. So we write our equation, the number of hours equals K on T, temperature. It says the temperature is 30 degrees, hours is 8 hours. So 8 equals K on 30, K equals 30 times 8, which is 240. Are we weak at that? Did we not recognize that, or did we not get up to it? I don't know. So if we're weak, so I know that we need to work more on that. Those styles of questions. If we think we're okay, I'll just continue. Weak or?
Oh no, I just used a different equation for.
What's your different equation?
Yeah.
Well, it's not done yet. I'm not finished.
Yeah, I know what I'm saying. I did it before.
H equals 240 on T. That's your new equation. And of course, it says how long will it take for the same size of block of ice to melt at 12 degrees? H equals 240 over 12, which equals 20 hours. Does that make sense? Looks familiar to you, especially number 6. Thank you. Leanne wants to build a rectangular vegetable garden in her backyard. She has 20 meters of fencing and will use a wall as one side of the garden. She has 20 meters and use the wall as one side. So this plus this needs to become 20 meters. Is that correct? The plan of her garden is shown where x meters is the width of her garden. Which equation gives the area A of the vegetable garden? Ooh. Okay. To find area, let's talk about that first. Area equals to what times what? For this case. Why do we stall? Stop stalling. Area equals
L times B.
L times B, base times height, whatever you would have said. So I'm going to use base times height. Now, we have the height, which is x. What would be the length of the base? Anyone can think. I'll highlight it a little bit more. But you've got to think. You can't just say it's 20. Think what I've shown you in green, and I said that equals to 20. Any ideas?
So.
No. A little bit of algebra. Joey, any ideas at all? 5. It's not an actual number.
Oh.
What if I said that? It's not a number. It's an expression. I'm not talking about x squared. I'm not getting the area yet. I'm just working out the base. Do you have any ideas of it? Okay. This is x. This is also x. What do we know about x plus this length, which is my base, plus x? What do I know about my x plus b plus x? What does it add up to? X plus b plus x must add up to 20. Well then, isn't this true? X plus x is 2x. I move it over. Don't I get b equals 20 minus 2x? So isn't the base just 20 minus 2x? Isn't the base just 20 minus 2x? Think about that for a second. So if x was 3, if this was 3, isn't this also 3? So then 3 plus 3 is 6. Isn't the base going to be 14? 20 take away 6. Do you see how it works? Yeah. You need to know that, the algebra behind that. And then once you now know the base, which is 20 minus 2x, 20 minus 2x, what would the area be equal to? Well, how do we expand this? Joey, you should be really good at this. Expand this.
20x minus 2x squared.
Yeah, done. 20x minus 2x squared t. Actually, very likely you'll get something like that now in the HSC, even more than back in 2013, because now there's common content between advanced and standard, and that is actually an advanced topic. I actually get that. It's called max-min problems. You probably remember this. So, actually, if I could say anything, I bet a lot that would be the exact question you probably get. Because last year I know what it was. It was part of the linear stuff, so I think this year is going to be this one. Anyways, moving on. But do we get the logic of it? Very straightforward. We had already mentioned that everything in green here was going to add up to 20. So I used that logic to find my base. Right, there it is. X plus B plus X minus 20. Sorry, equals 20 should have been. All right. I think we get it. Number 7. Let's read again. The height of a particular termite mound is directly proportional. All right, if it's directly proportional, is that in the denominator now? No, it's not inverse. If it's inverse, it's in the denominator. So height is directly proportional. That means K times the square root of the number of termites. Square root T. You need to, so step 1, you've got to write an equation now for these questions. Step 2, always finding K. So how do we find K? The height is 35 and the number is 2000. So H equals 35, T equals 2000. Therefore K equals 35 on square root of 2000. Whatever that is. Someone can give me a rough answer. 0.78. Then we're going to times that number by square root of 10,000, right? Because it says, what is the height of this mound when there are 10,000 termites? So now that you know what K is, you write H equals 0.78 times 10,000. Obviously, the answer is 78. So what's the hardest thing with this? Creating your equation. Any questions? Those at home, any questions? No? Okay. I will have to get you guys working very soon, so probably do 2 more. Actually, we'll do 10 questions in total. We'll do the first 10, and then I'll get you guys working to see how comfortable we are with these questions. All right, this was from the 2009 question 28C. 28 wasn't that bad. All right, so let's see. The height above the ground in meters of a person's eyes varies directly with the square of the distance in kilometers that the person can see to the horizon. Okay, full stop, stop. What's the equation that we want? So H equals varies directly with the square of the distance.
K times D squared.
I like it, D squared. Whereas, wait, I'll just scroll up for a second. This one said square root. That's why I put it in square root. Good. This one says D squared. I write that. Perfect. It said directly, so we just times it. If it said indirectly or inversely, it would have been K on D squared. Move on. A person whose eyes are 1.6 meters can see 4.5 kilometers out to sea. So H equals 1.6 meters equals K times 4.5 squared. So what does K equal to? 1.6 on 4.5 squared. K equals to 0.079. Step 1, step 2, and we're up to step 3. 3 marks. Step 3 would be, how high above the ground would a person's eye need to be an island that is 15 kilometers out to sea? So H equals 0.079 times 15 kilometers out to sea. The answer is, to 1 decimal place, 1.2 meters.
Do you not square the 15?
Ah! Of course you do. Sam did a mistake. Divide by 15 times 15 squared. I thought it was too small. I was just about to look at it. I'm like, doesn't make sense. That's all right. 17.8 meters. So we were okay with it?
Yeah.
Questions? Done. All right. Question 9. And Charlie, and are we seeing a repetition in styles of questions? All right, every single one here is from the HSC. Every single one, as you can see. Now, given the years, I give you wherever they are, so that should build up a lot of confidence with you guys as you keep doing papers over and over again. And Charlie is investigating stopping distances for a car traveling at different speeds. To model this, she uses this equation. Fair enough. What kind of function is it? Parabola, where D is the stopping distance and S is the car's speed. Fair enough. The graph of this equation is drawn below. All right. Makes sense. There's D. D is on your y-axis. There's S on your x-axis. And Charlie knows that only part of this curve applies to her model for stopping distances. Only part of the... Hey, does that sound familiar with what we were looking at before? In your writing booklet, using a set of axes, sketch the part of this curve that applies for stopping distances. Okay, well, which part would work and which part makes absolutely no sense?
The negative doesn't make sense.
For both of them? Right? Think about it. You can't have negative stopping distance. That doesn't make sense. You can't say you've stopped -5 meters. And can you have a speed of -60? So they both have to be positive in this case. So I'm going to highlight the answer. It would have been this. That, and then of course the graph we're actually interested in is that. Without having to obviously redraw it. That's okay. Let's read the question again. Anjali knows that only part of this curve applies to her model. Using a set of axes, sketch the part of this curve that applies for stopping distances. And we just did that. 1 mark, 2 marks. What is the difference? What is the difference between the stopping distances in a school zone when traveling at 40 kilometers an hour and when traveling at 70 kilometers an hour? All right, there's 2 ways to do this. Give me the 2 ways. There would be 2 ways to do it. Both ways would be fine. Obviously, the first way is to use what? Read the question again if you haven't absorbed the question. What is the difference between the stopping distances in school zone when traveling at a speed of 40 and when traveling at a speed of 70? The first method is to use the equation. Second method is to use the graph. I thought the first way would have been the graph, but anyways, first way, equation, second is graph, up to you. So let's do both, just so that we're comfortable with both. All right, this was actually last year's HSC. It was, instead of it being a parabola though, exactly this question, instead of it being a parabola, it was a straight line. So it wasn't that bad, but here we go. If we did the graph first, speed of 40, so you would go to speed of 40, go up, and that looks about 41. So this is going 50, so 42, sorry. Unless my eyes are, nope, 44, 44. Thank you, 44. And then at 70 k's an hour, oh, well, that's when you can't use the graph and you have to use the equation. Oh well, good enough. D equals, what do we have? 0.01, 0.01 s squared plus 0.7 s. Okay, here we go. At s equals 40, D equals, sub it in, I got 44, which is, we already know that anyways, but at s equals 70, D equals 98. Answer the question. Difference is 54. So you travel an extra 30 k's an hour, you will stop 54 meters more than if you were traveling only 40 k's an hour. Quite amazing. And it is exactly true. The only thing that this isn't taken into account is your reaction time. Because if you react slow, therefore your distance is going to keep going by the time you react, and then there's your stopping distance. So it's actually a lot more than that. Quite scary. That's why the school zones are obviously only 40 k's. Last one for me, and then we'll see if you guys feel comfortable, you can do a few. And if you're really comfortable, maybe we can go to school-based topics and then just get this done in the course of your week. Let's do it. Algebra 2, Unit 2011, HSC, question 28A. All right. The air pressure, P in a bubble varies inversely. P inversely with the volume. Write an equation related. We already know that. But it says using A. So this time we're going to write P equals A on V. Did you say P equals V? 3.
Because
Right, that's double A.
question is
Double A, don't mix it up. P equals A over V. It is known that P equals 3 when V equals 2. Find A. Well, P equals to 3. A on V is 2. What would A equal to? 3 times 2? 6. With me with that? And then, of course, what's your new equation? P equals 6 on V. What does V equal to? The question says, find also the value of P when V equals to 4. 6 over 4, which is 1.5. Christian, kept up with that? You okay? Am I doing anything in there that we're like, I'm confused? I need to know so I know to go through it. Because I didn't go through the theory, as I said. I'm just doing exam questions straight away. Seems okay? Seems like something we could do, all right? Sketch a graph to show how P varies for different values of V. Before we sketch the graph, what kind of graph is it? It's a hyperbola. So now that we know it's a hyperbola, right, because it's on V, anything on a pronumeral is a hyperbola. So we're trying to draw this. P equals 6 on V. We know it's a hyperbola. We know hyperbolas look like this. If I have both positive and negative, you won't, again, will you have negative volume? No. So therefore, well, you're going to ever have the left-hand side? Also no. So really, it's just going to be the right-hand side. You will get marked down if you drew both. Because it's not applied to the question. If I just told you sketch a hyperbola, you will get marked down if you don't draw both. But in this case, it's not just a hyperbola, it's also the fact that X values are going to be positive because volume is always positive. But don't think always everything's positive. As I showed you, cost can be negative. You gotta look at the application. People can't be negative either. So you got to look at you got to learn temperature. Temperature can be negative. So then that one would work. You got to apply. Stopping distances, we just saw, cannot be negative. Money can be negative. So that would be like that. What other questions are there? I'm thinking. Blood alcohol content. Can you go below 0? That also cannot be negative. You either don't have any alcohol in your blood or you do. Really, you can't have negative. You can't be creating alcohol in your blood. That doesn't make sense. So no negative. Can you have negative energy? Also no. You're either producing energy or you're not producing energy, so it's 0. All right. What other applications are you guys learning in your course? Medication. Can they be negative? I don't understand that. Nope, no negative. Also has to be either positive or none. So either giving or 0. Kilobytes, bytes. You either have CDs, DVDs, music on your Laptops, so there's storage, or there's none. Can you get negative? I guess the only way you can get into the negatives is if you're deleting movies, right? Or music or whatever. You're subtracting, but you're not going to get any more than 0. You're not going to go below 0. Does that make sense? So if your computer's at full capacity, there'll be 0 data left. It will never become negative 0 data left. Negative 1 data or 2 data, whatever. 2 gigs. You'll never have negative 2 gigs. So pretty much those are all the applications you should ever see. Good. Moving on. All right, so the answer that we're looking for obviously looks something like this. If you drew that, that is only 1 mark still. Label is still 1 mark. How does that green one look any different to something like that you could have just drawn out of thin air? How does that specifically explain it's this, other than labeling? Because I mean, I would just say it's a hyperbola. How do I know it's specifically that 6 over v? So there's just this one extra step that they're starting to make everybody do now. You have to actually plot in a point. So you plot 1 point. So that means the point you plot, the easiest point to plot is the one you just found up here. When v is 4, so you got to actually write it 4. What does p equal to? You got to show us that. You got to actually show us that. That's all. Then you get full marks now. And if you want to label, that's good. Good for you. If it was worth 3 marks, you probably should label, because then you will lose a mark. 2 marks, you won't lose a mark for labeling. But you will lose a mark for not putting the point, because like I said, how do I know that's any different to the black one I've drawn here? They're both hyperbolas. So, going to be a bit more specific. All good? My turn or your turn? So, a few more, or you feel like you want to try it first and see? Happy to try? Okay. So, I'll pause the record.